Okay, okay, it's 10 o'clock on my computer, so let me take a few minutes and welcome everybody here. Uh, Most of you are getting used to the protocols for video meetings, but let me go over those real quick. If you can, keep your mic on mute. Post any questions that you may have during the webinar up in the northeast corner of your screen to the chat section, and please do not press to present your own screen. We had that happen last week, and that's last month, and that was a little bit of a debacle. So if you can, just recognize that this is being recorded, and keep your mics on mute, and let Doug present. And so without further ado, we're going to try to get a lot of material in over an hour. So let me go ahead and introduce Doug Armconnect. Doug is a veteran MyTopo cartographer, and my name is Paige, and I've been here since 1999. And in the more than a decade or so that we've been working together, I've yet to see a customer or colleague ask him a map-related question that he wasn't able to answer. So I think we all have a lot to learn from Doug, and I will turn it over to him now. I should also add that this meeting is being recorded. If anyone does not consent to that, please drop out. And we will have this available for you to view on the YouTube. Terrain Navigator Pro has a YouTube channel, and the videos are always posted there. We're also going to add this one to the MyTopo website as well, and we're hoping that you'll all be able to use it to in your own efforts to inform your friends, family, colleagues, peers, Boy Scout troops, those kind of things. Inform them how to navigate, so we can keep each other all safe, which seems to be what we're all trying to do here in this crazy pandemic. So without any further ado, let me turn it over to Doug.
All right, thanks so much, Paige. I have been with MyTopo since 2007, I believe. And so I've been working with maps with MyTopo for quite a while, but I've been interested in topo maps for quite a bit longer than that. And I've been drawing maps myself since I was 10 years old. So I really enjoy maps, and I'm excited to see so many of you here. It's an honor to be able to present to you. So let me just go over a quick overview of what we'll look at today. First, just a brief history of topographic maps in the US, so we can just see why or how we got to where we're at today. We'll take a look at map symbols, which sometimes people have questions about, and how you can figure out what those symbols are. I'll show you briefly how to set up a MyTopo map. That's not really the focus of this webinar, but our process has changed a little bit, so I'll show you some of the new and exciting changes there. And we'll look at some of the features that you can put on your map. And coordinates is a big question for navigation, so we'll take a look at coordinates, different coordinate types, and how to use those on the MyTopo map. And finally, just some different safety practices so you can use your maps to navigate and get yourself where you need to go safely. So like I mentioned, I really do enjoy maps. I love maps, but to me, the most fun part about maps is where they get to take you. So this is me with my wife, Kelly, in Utah at Angel's Landing, and this is one of the many places that I've been able to go safely thanks to MyTopo maps. And we hear from a lot of customers and about the things they've been able to do with their maps, whether it's hiking, camping, hunting, just hanging on the wall to enjoy, whatever. So yeah, just last week, this is my family in Minnesota. We were near the headwaters of the Mississippi River and using MyTopo maps to navigate in that area. So there's a lot we can do with maps, and we'll take a look at some of those today. So just looking back in the US, the US Geological Survey has been producing maps since 1879. And so as far as civilian maps goes, they are the main producers of detailed maps across the full US. So they started in 1879, and you can find a number of historic maps dating back, even to the 1800s. But in 1947, they began a program to produce maps at 1 to 24,000 scale, which is pretty detailed across the full US. These are the quadrangles or the 7.5-minute maps. It was a pretty massive undertaking, and it took from 1947 to 1992 to actually cover the full US with 55,000 of those maps. So many of you are probably familiar with this. It was a really massive undertaking, and it's pretty cool that we have, as of 1992, we had very detailed maps of any location in the US. Now, from the 1970s through the 90s, they did some updates on that series of maps, but it was never really a regular set of updates, and so some maps never got updated since the 1960s or 1970s. Some were updated a few times, but it was never really a regular thing. So in 2009, the USGS began a new program called the US Topo series, and they've been producing those maps for a little over 10 years now. And that's mainly a digital product, and there's several advantages to it. One is that since it's all digital and a lot of the process is automated, they're able to produce that series a lot more quickly, and they're able to do updates on those maps a lot more frequently. So I just want to show you a little bit of that US Topo series. I did mention that's primarily a digital product, but we do prints of these as well. So you can go onto our website and you can order some of these maps. So this is a US Topo map in Colorado, Trappers Lake area. And you can see that it resembles a classic USGS quad in quite a few ways. It has the contour lines, water features, trails, roads, and so on. But there are some differences. So let me just compare these. So this is the classic quad of this area. And the classic quad has some of the features that are not yet reflected on the US topos. For example, you'll see it has something like things like the Trappers Lake campground here. It has a spring. If we switch on over, it shows that there's campgrounds, but it doesn't really tell what it is. It doesn't really show the spring there. So there are some features that are still missing from the US topos. On the other hand, they are more up to date. For example, if you look at the classic, it's hard to see, but there's a couple of old trails here. So this is a 1977 map. In the newer 2016 map, it's been consolidated into one trail. So things like trail differences, new roads, subdivisions, those are more accurately reflected on the newer maps. So, but a lot of our customers do prefer the classic quads. They have just kind of a more personalized feel, and they do have some features, let's say spot elevations, that are not yet reflected on the new US topos. So a lot of people go on and even order one of the old quads and one of the new quads just to have those. So we're kind of at a transition period right now in topo maps. There's some exciting stuff to come, but there's still a lot we can get from the classic quads. And when you set up a topo map on our website, for now we are still using the classic quads. But I'll show you how you can get those set up, whether the classic quads or the new US topos on our website. All right, so let me switch over and show you some topographic map symbols. And sometimes people ask us, why don't you put the legend right on the corner of the topo map? And I'll show you the reason right here. This is the topographic map symbols pamphlet from the USGS, the digital version, and it's 3 pages long. And so it's not really practical for us to put all of this onto every single map. Now, most of the maps don't need all of these symbols. A lot of these are very specialized, and they do not occur on most maps. So for the most part, it's really just some of the just the regular, most common symbols that you need to know, and I'll go over those. But should you happen to need to know some kind of more detailed or obscure symbol, you can find that in this pamphlet. You can search for topographic map symbols from the USGS and bring that up. So I think Paige mentioned, if you do have any questions, put it in the chat window in the top right corner, and I'll be checking that periodically. Just feel free to type your questions into the chat window, and I'll check on those and answer those the best that I can. Okay. Go ahead and move on and show you our homepage. Go to MyTopo. When you go to mytopo.com, right now the page looks like this. This is going to be changing probably within a few days or weeks. So just be aware, this is the classic look of the mytopo.com. If you come to the page, it will be a more modern interface soon. But we've already changed our search page. So to bring up a map, you're going to go ahead and go to Find a Map. And usually you're going to want to search for your location, but let me just show you briefly the quads that I mentioned, the US topos and the standard quads. You can order those right here under USGS quad sheets. Select the state that you want to go to. Go to the quad topo maps option, and you'll find the name of the quad that you want. And it will show you different options. So in this case, we're showing you the 2015 US topo map here and the classic quad, which is from 1996. And so for each of these, you can click on the image to enlarge it. Look in the lower right corner. You can expand this and really zoom in on it. This is not the full detail, but it at least shows you just the detail, a little bit more of the detail, so you can see if this is a map that you want. So this classic quad, you can add it to the cart and order it here, or the US topo, the new quad, or the classic quad. You can also take a look at this preview, see if it's what you want, and order it there. So just want to make you aware of that from the website, how you can get the US topo or the classic quad. Another option that we have on our website is hunting unit maps. You can find those here, and you can select the state that you want and order the hunting unit map by GMU or by species or whatever number that you use to differentiate the different hunting units. So those are a couple of stock maps that we have. You just place the order, you don't customize it. I just want you to be aware of those. But normally you'll go onto our website and type in the into the search area here. Type in what you want to bring up. And after you type it in, it will come up. If it doesn't come up right away, you might want to put in your state or state abbreviation. And you'll click on the result. And that brings you up to this map page where you'll be able to move the map and get it exactly where you want to be at. So don't get too worried about what it covers on this page. You mostly just want to center up the map. So I'm on Wild Bill Lake, looks good. I want to make a custom map, so I'll click on that. And you have different options. We'll choose custom topographic map for now. I think in the future we may do a webinar about more details on how to set up a MyTopo map, but for now I'm just going to kind of breeze through it. I do want to bring your attention to, we have a hybrid map option, and that looks like this. That gives you the option of contour lines from the topographic map, but it also shows the underlying aerial photo, which comes in handy for showing things like rock outcroppings, where vegetation is at, and so on. So that's an option under the hybrid map. But for now, we'll just leave everything as is. The red box shows what I want to cover. I'll continue on. I'll select a folded waterproof map, which is great for outdoor use. You can put in your title and your name, but I want to call your attention to these navigation grids, since that's what we're focusing on today. For latitude, longitude, degree, minute, second grids, you can select no grid, tick marks, which just puts the numbers on the edge, or full grid lines, and you'll see that's reflected here. And UTM grids, you can select tick marks or full grid lines. In this case, I'm just going to do tick marks, and we'll do enhanced topo with relief shading. Makes the map look really good. And go to the preview page, view a preview, and then you can go through the order process. So I just want to briefly skim through this. I'm sure many of you have made maps from us before and ordered maps, and I want to show you the new process. So the preview will come up, you'll place the order, and I'm just going to skip ahead to when you have the map in your hand. And since I can't physically show you a map, I'll just have to show a proof of it on the screen. So this is the map that comes up. I don't see any questions in the chat, but again, feel free to ask at any time. So this is our map. You'll see the main map area is here in the center. On the right side is border information. And I want to briefly go over that. So you have your map title. This is a unique map ID that can be used to reorder the maps. If you scroll down, it shows the vicinity map, your location within the state. And then source map information. We were looking at quadrangles earlier, and the source map information shows which quadrangles make up this custom map, since your map is probably going to span more than one quadrangle. And that shows the name of each quadrangle sheet, and the date of the original information, the original imagery. All right, scrolling down, we have a north arrow with different forms of north, your scale, and your scale bar. And we'll go over these in a little more detail as well. But first, let's take a look at the different symbols on the map. So one of the most important symbols on a topographic map is the contour lines themselves. And these are the brown lines that indicate areas of elevation. Now, if we find some of these lines, let's say this one says 6,000, that indicates that every point along this brown line is at 6,000 feet of elevation. This one is 6,400. Same thing, every point along this line is 6,400 feet. And each additional brown line indicates a change in elevation. Now, you might be wondering how much change in elevation, and to find that, you want to find the contour interval. You'll find that on the edge of your map under the source map information. And you can see that each of the quads that make this up has a 40-foot contour interval. So each line is going to indicate 40 feet of change. So if we're starting at 6,200 feet, the next line up is going to be 6,240, 6,280, 6,120, 6,160, and finally 7,000. Or 6,400. And if you follow this line along, there you go, 6,400. So you can use these contour lines to find what this landform is actually like. And it takes a little while to understand how to read contour lines and really see it in your head. It helps a lot if you turn on the shaded relief, which I did on this map, and you can kind of see, oh, there's a peak up here. You know, there's a little canyon here. There's a valley down here. It helps to see that as well. A couple of things to keep in mind as far as the contour lines go is if you see very few contour lines like this area, this is a flatter area, very little elevation change. If you see a whole bunch of contour lines stacked up together, like right here, that is a steep elevation change, a steep cliff or a hillside or something like that. And you can see other features start to come out, like this is a ridge right here with steep areas on each side. The ridge is here. You see things like canyons and valleys, and there's a technique you can use on those. If you find a creek or a river or something like that, you'll see that the contour lines form V's as they come up to that creek. And you'll look and see that all the V's point in a certain direction. And the V's always point upstream. And so if you're looking at this Dutch Creek here and you see these contour lines, you know there's some kind of little canyon or valley here, and the V's are pointing upstream, which is up to this peak. So that can help you understand whether the contour lines are going up or down. And then you can know, okay, well, here's the top of the mountain up here, down here is the valley, and we're going uphill from here to here. So it just takes practice to look at topographic maps and understand whether you're seeing, you know, rise, a fall, a ridge, a valley, so on. But that's just a quick introduction to that. I'll take a look at a few other symbols on the map. The maps show things like waterways, creeks and rivers are in blue. Lakes are also shaded blue, like this one, little tiny pond there. We have roads which have different symbols, but they can be double lines like this. They can be dashed red and white lines, a solid red line like this. These are all roads. It's a gray line. Trails are indicated by dashed lines like this. And if you see little black points on the map, these are individual houses or some type of building on the map. Okay, I see a few questions coming across. There's a question about grid lines. I will answer that in just a moment. The question about when selecting UTM for the new US Topo series, we would select USNG. When you order a US Topo series map from MyTopo, that's going to come with the UTM grids on the map by default. You don't really have any option to customize it, but the UTM grids are on there. Okay, a question about latitude, longitude versus UTM. Why choose one or the other or both? I'm going to go over each of those grids, and hopefully that will help you understand those. And finally, do you offer maps in different scales other than 7.5 minutes? All of our custom maps are based on the 1 to 24,000 scale, 7.5 minute. So that's our only base map that we offer. You can rescale those when you go to set up the map. You can choose a different scale. If I just go back here real quick. For the most part, we recommend staying close to 1 to 24,000, but you can select all the way into 1 to 10,000, zoomed in, or zoomed out to 1 to 50,000. If you zoom out past about 1 to 30,000, it gets hard to read. If you zoom in really close, the map starts to get pixelated. So usually around 1 to 24,000 is a good place to stay. Okay, so let's take a look at all the different lines that are going on this map. So the red lines with red numbers in the center, you'll see these mostly in western states in the US, places that have the public land survey system. And what this indicates is this is a section. The section is usually around 1 mile by 1 mile, 1 square mile. And the number in the middle indicates a section number, which usually goes up to 36 and then starts over at 1 again. Now, these are on the original topographic classic maps. And so there's no way to turn this on or off. It's on the map. So regardless, even if you turn off all the grids, the section lines are going to be there. So those are the red lines. Don't get confused by those. Okay, the other lines that we have on this map, it's a little hard to see, but I've turned on latitude and longitude lines. And on the final map, they're a lot more well-defined. But these black lines going throughout the map, this is latitude, longitude grid. And you can see if you follow the black lines, you'll find a number on the edge of the map. Okay, the blue numbers and blue tick marks are the UTM tick marks, which I selected when I set up the map. And so that's the UTM grid. Occasionally you'll have other things on the map, like your map may have grids that were already on there. And unfortunately, some of the original USGS maps, they had UTM grids embedded on the map. And so they were scanned in. And so even when you turn off all the grids, that UTM grid is still on there. We call that an embedded grid. Unfortunately, there's nothing we can do about that, but there are a few locations where that's true. Okay, so let's look in detail at latitude and longitude grids to start with. So along the top and bottom of your map, you'll have the numbers of longitude. In this case, 109 degrees, 16 minutes, 30 seconds. Now it gets a little confusing because when you say latitude, longitude, you can still have different formats. You can have decimal degrees, which looks different than this. But for our maps, we use degrees, minutes, and seconds. And so the third number is seconds. It goes from 0 to 60. Minutes goes 0 to 60, and then degrees. If you have a decimal degree coordinate, it looks more something like this. 45.2, negative 109.458. So if it has a decimal like this, it's probably a decimal degrees, or in some cases it may be degrees and minutes with decimal. Like I said, it gets a little complicated, but I'm going to show you just briefly how you can turn a decimal degree coordinate into a degree minute second coordinate, which is what we use on our map, and how to plot it on the map. So there are a number of tools you can use online to convert decimal degrees to degrees, minutes, and seconds. That being said, if you have your GPS and you want to use it with our maps, you can set your GPS up for degrees, minutes, and seconds, and that way it will line up perfectly with our maps. But let's say that you did have a degree, minute, second coordinates. You can go to an online tool. This one is from the FCC. And let's bring that up. So we have 45.2, negative 109. I'm going to convert that from decimal degrees to degrees, minutes, and seconds. 45 is our latitude. 109 is our longitude. So that comes out to 45 degrees, 12 minutes, and negative 109 degrees, 27 minutes, and 30 seconds. So we can actually switch over and plot this on our map. Okay, so we had 45 degrees, 12 minutes, and then negative 109, 27, 30. Okay, here's 45 degrees and 12 minutes. And here's negative 109. The negative just means west. So 109 degrees west, 27 minutes, 30 seconds. So that point from your GPS or decimal degree would be right here, 45, 12, 109, 27, 30. Right here on the map. Usually it doesn't end up quite that neat, but that's in part why we recommend UTM coordinates, which I will go over in just a moment. Let me take a look at questions again before I move on. Okay, so next question is, please describe the overlays you offer, for example, parcel data, geologic data. We do have parcel data on the MyTopo site. When you're setting up the map, in most locations we have a private land boundaries overlay. You can turn that on. That's, I would say, the main overlay that we offer. There's also some hunting unit overlays. Those are the main ones that we offer. That's a little out of the scope of this presentation, but again, in a future presentation, we may go over how to set up maps and different things there. But yes, we do offer private land boundaries when you're setting the map up. Next question, is it possible to have some fraction of 1 to 24,000, like 1 to 6,000 to show more detail, still be able to use a grid reader to scale? You can have different map scales, like I showed you, 1 to 10,000 on up to 1 to 50,000. And you can use a grid reader with those if you have the correct grid reader. Let me just switch over real quick to, we don't sell grid readers ourselves, but if you go to maptools.com, they sell a number of these overlays. And you can put these over the map using the UTM grid, which I'm just about to get to. And they sell different scales that work with pretty much all of our maps. So this is a 1 to 24,000 scale, but I'm pretty sure they offer things like 1 to 10,000, 1 to 15,000, and so on. So yes, to answer your question, it is possible to get a more zoomed in map, but to get a grid tool that will work with it. Okay, next question is, classic topos had splined labels for mountain ranges and ridges. Do the current maps allow options for how these spline labels appear? Well, when you reference the classic topos, when you set up the map on our website and get a custom map like this, we're using the classic topos. So however the map appears on the classic USGS quad, that's how it appears when you set up a classic topo. The new US topos, it really just depends on the location. You would have to bring those up. We do not offer customization on the US topos at this time. So it's just, that's the map the USGS creates, we print it. So if you have questions about that, you can look at the preview and take a look there. Okay, and next question is about topo maps downloaded on cell phone. And actually the question says, I was a customer of Terrain Navigator Pro, which is discontinued. Terrain Navigator Pro is not discontinued. We had a service called MapPass, which was discontinued. The MapPass is, as far as digital mapping goes, is being replaced by Terrain Navigator Pro. If anyone is still using MapPass, use the Terrain Navigator Pro, which is an ongoing, continuing product, and that does allow you to have the GPS, or have the app on your phone and have the your GPS location shown there. We're getting more questions there, so sorry if I can't answer that in full detail, but yes, there is an app you can use there. Okay. Yep, I see the page is answering my questions there. So, all right, I better continue moving on. So we've looked at latitude, longitude numbers. Those are the black numbers on your map. The blue numbers are UTM, and UTM stands for Universal Transverse Mercator. kind of a geeky projection thing going on there. But UTM is really handy because just the way it's set up and the way you can subdivide it. UTM and MGRS military grids are very similar. And so when you turn UTM on our maps, you can also use MGRS military grids, similar numbering system. And yeah, if you come from a military background, you should be very comfortable using this on our maps. So the blue numbers are UTM, and on the top of the map, these are called the eastings. On the side, it's called the northing. The easting is 6 digits, 634000, and the northing is 7 digits. So let's look at some coordinates here. We have 634000. The next one over is 635000. So this is a 1,000 meter or 1,000 difference from here, and each of these units is meters. So on this map, at least, between each of the points here is 1,000 meters. So each grid square is 1 kilometer by 1 kilometer. So it's really handy because what you can do is you can divide that 1,000 meters down into 100 meter segments. This is this grid tool I was looking at. And by doing this, you can pinpoint your location to within 100 meters or even 10 meters or even less. And the way that you're going to do this, we switch back here, you'll get a UTM coordinate from your GPS or some other source. It starts with a number, in this case 12, and that just refers to the zone number. You look on the map, it's going to show UTM zone 12. Just make sure that you're on the correct zone on your GPS, which should be automatic. Okay, it's going to show you a series of 2 numbers. First one is 6 digits, and you can probably guess that's the easting. And the second one is 7 digits, that's the northing. So we'll go on up here. We've got 635,700. So it's going to be between the 635 and the 636. And you see it's 700, so that is 70% of the way over from here to here. So if you overlay that grid tool, you can count off 7 of the squares, and you'll wind up somewhere in here. That's your easting. And then from your northing, it's 5006,350. So here's your 5006. And 350 is going to be 3.5 of those squares if you were to have the overlay. So I'm just estimating here, but that coordinate should be somewhere right in here. Use that grid tool and really look closely. You can get a much more precise location. Now, I did mention the MGRS military grids. If you're familiar with that and know how that works, you should be able to get it to work fairly easily. You'll use the same numbers on the edge. The only difference is you have the addition of this 2-letter grid zone identifier. And if you look on our map, you can look on the edge of the map, again under the scale, the projection information, and that tells you the grid squares that it's using. In this case, it's using 2 different grid squares because it has a point where it changes on the map. So it shows it here, X-ray Romeo or X-ray Quebec. So UTM, MGRS, UNG, USNG, those are all similar. There's a lot more detail I could go into, but we'll try and keep it brief for this presentation. But very powerful. I would really recommend using UTM if you haven't already, just because you can use that grid tool and you can really precisely find your location. All right, let me take a look and see what kind of questions we have. Okay, yes, I'm going to mention datums right now. So when you're setting up your map, go back on the MyTopo, you have the option for your datum GPS setting. This is a point of confusion for people, but don't get too confused. In general, you want to leave it on the standard NAD 83, WGS 84. The reason you want to leave it on that is that any modern GPS is going to default to that, and so you'll have the correct coordinates. If for some reason you have a coordinate or an old GPS plot that is from NAD 27, you might want to switch your map to that. That is an option. But the key point is just make sure that whatever coordinates you have are using the same datum, which lately, especially if you're using a newer GPS, should always be the case, but just make sure that you don't have a mismatch there. If you have a mismatch, you could be off by a couple 100 yards or more in each direction. Okay, and scale, I'll mention that just briefly. So for scale, we have the set on 1 to 24,000, and people get confused sometimes. They say, is that 1 inch is 24,000 feet, or what is that? When it shows a scale and it has your colon there, what that means is that 1 unit on the left side is equal to 24,000 units on the right side, same unit. So 1 inch on your map is 24,000 inches on the ground. Divide that by 12 and you get 2,000 feet. So 1 inch on this map is equal to 2,000 feet. If you measure out 2 inches on your map, it's going to be 4,000 feet on the ground. And you can also use these scale bars to find your distance in miles or kilometers. So if you have a different scale, 1 to 10,000, 1 to 50,000, just make sure that you change it up and use whatever you have it set to. Okay, I'll pause for just a moment, and if you have any questions about that. I know we're covering a lot of ground just about coordinates and scales, datums, and so on. It gets a little confusing, but if it's all new to you, keep working at it. It's worth it. You can really get a lot more use out of your maps. Okay, next question. Some maps have the NAD 27. Why is that? Some of the original USGS quadrangles, classic quads, if you get an actual print of it, not from us, but from somebody else, they will have that. That's just a standard that they used for a time. That's just stands for North American Datum, and it's just the control standard that they used until NAD 83 became a lot more popular. That's just what they used. So if you have some coordinates or an old map or something that you want to correlate to NAD 27 and you want to use coordinates off from our maps, just select that when you're setting the map up and make sure that you're using like coordinates. There are ways to convert between it, but it's just a lot easier to use the same datum. Question is, match the map datum to what? When I say matching the map datum, it's just a question of coordinates. So let's say somebody hands you a set of coordinates and says, okay, here's this coordinate, where is this on the map? Well, you need to know what's this coordinate from and what's the datum for it. If it's from a GPS and datum is set to NAD 83, then you're good. It's going to work on this map. If the coordinate is from, who knows, a surveyor that was using NAD 27, you might have a problem. So it's just a question of when you're looking at coordinates on our map and comparing them with coordinates from some other location, make sure they're using the same datum. Okay. All right. I'll go ahead and move on to using a compass on the map. And this could be an entire webinar by itself, but I'm just going to go over this very briefly. This is actually a page from maptools.com. They have a lot of really great resources. This is the page here. So it's about using north arrows on the map and navigating with the compass, overlaying your compass. The point that I want to make on our maps is to look at this north arrow. It's a little confusing because when you're talking about north, well, we have 3 norths on our map. The first is grid north, which it shows at the top, GN. Grid north is what the edge of the map is aligned to, and it's what the blue UTM lines or the ticks are aligned to as well. And grid north is off by true north by just a little bit. And true north is what the latitude longitude coordinates are using. So if you see the latitude longitude grid as it comes down here, it's just a little bit misaligned from the edge of the map. That's not a mistake. It's just because our map is projected with the UTM projection, And just the way the projections work, there's just a little bit of discrepancy there. So in this case, it's 1 degree off. Now, the reason this is important is because if you're using your compass, you're going to align your compass with something. And in most cases, you want to align your compass with the grid on the map. I could have done full UTM grids. It could have made it easier. But if you're aligning your compass with the edge of the map or the UTM grids, what you're using then is grid north. And what you need to know is the difference between magnetic north and grid north, so you can figure out your declination or your inclination. And our map is showing you that it's 10 degrees. And so magnetic north is 10 degrees of grid north. And as long as you're lining your map up with the UTM grid or the edge of the map, you're going to use a 10 degree declination there. Okay. True north is 1 degree off from that. So if you were to align your compass with the latitude longitude lines, which are true north, that's an additional 1 degree. So you would have an 11 degree difference between true north and magnetic north. All right. Yeah, as Paige is showing in the chat, we do recommend map tools for great grid tools, and they just have a lot of good information on navigation. But just pay attention to your north arrows and your magnetic north when you're going to be navigating with the compass. Okay. And if you get a nice and fancy compass, you can program that magnetic north right in there. And that way you'll have it all set up. You don't have to figure your declination all the time. Just add it in there. Final thing I want to look at is once you have your map and you're out on the trail, it's really important to stay found, because one of our customers for a lot of our products is search and rescue groups. And it's never fun to have to find somebody out there who's lost. So when you have our map, you already have a great tool. So go ahead and use it. Just know where you're at all times. It's not always possible to pinpoint exactly, but just as you cross different references or places on the map that you can see, just know that, okay, I'm between this point and this point, I'm between this creek and this trail junction, and so on. Just reference your map frequently so you know where you're at. It's also helpful to look at your map and mark it every 30 minutes and say, okay, you know, I was at this place 20 minutes ago. Okay, now I'm at this location, just mark a little X there. And that way you can always be reasonably certain of where you're at. And if you need to backtrack or whatever, you know approximately where you're at. So maps can just provide a lot of fun for you. If you don't enjoy maps just for their own sake like I do, hopefully you enjoy the places that they can take you and the fact that they can take you there safely. We're just happy at MyTopo to produce maps that help people have fun and enjoy what they're doing outdoors safely. So, all right, I know we've covered a lot of ground today. Hopefully most of it has made sense to you, but yeah, I would really recommend that you improve your map reading skills, improve your navigation skills, so you can, yeah, so you can enjoy your time in the outdoors. I'll take a look at additional questions now, and feel free to type those in there. Okay, so Bruce says, magnetic north varies. Are your online maps adjusted for that periodically? When you order a map from MyTopo, we use magnetic north. When we print the map, we use magnetic north as of the day that was printed. So that's going to show you on the map. Our online maps, we do have some online mapping products and software like Terrain Navigator Pro, and those do allow you to do real-time magnetic north, yes. The question about covering GPX files, we did not cover the GPX file upload today, but I'll show you real quick how to do that. We began to understand that there's quite a bit more we can go about setting up a map, but I will at least show you. So on our home page, when you set up, go to find a map. there's an option here under Custom Map Tools to choose a file, and you can upload your GPX file that way. And then you can go on and upload the map, and it will allow you to choose your map. Again, we may have a future webinar that gives you a lot more detail about how to set up maps like this way. Let's see. Oh yeah, I will also show you the search by coordinate feature. When you go to our new search page, you can type in your location, your place name right here, and that's great for bringing up a custom map of a location. But if you have a coordinate or you want something else, you can use these features. So search by coordinate is right down here. And let's say you have your coordinate like we just had before. We'll have our latitude and longitude. We're in decimal degrees. 35.2, and there's our longitude. So you put in your latitude and longitude. There are places here for different formats, degree minute coordinates, degree minute seconds like our map has on them, and finally UTM down here. But in any case, you'll put in your coordinates, click on go, and that will allow you to start building a map at that location. And that looks like that's at about the location we were looking at. Okay, question is, can you briefly go over triangulation with map and compass? Sort of. I'll show you a good reference for that. It's difficult to show you without actually being there with you. Again, if you go to Map Tools, they have some, let's see, really good tutorials here. This one shows you triangulation as far as it says here, location by intersection, or where is whatever that I can see in the distance. So you'll use your compass to find a bearing to whatever point that you're looking at, and then find a bearing to a different point and draw the lines on the map so that you can see where they intersect, and that's going to help you understand where you're at on the map. Again, just a brief overview, but this can get you started. There's a great tutorial here. There's other tutorials online, and we may do something in more detail in the future in a webinar too. Okay. And Paige wanted me to point out that on our web page, on our search page, let's go ahead and bring up a location here. When you're looking on this search page on our map, as you're moving your mouse around, it might be a little hard to see, but in the lower right corner, it shows you the latitude and longitude of the location that your mouse is at. So this is one way where you can find your latitude and longitude. And I think possibly even on our MyTopo online maps page, yeah, you can view free online maps here, and you can also see the GPS coordinate of the mouse on the screen down at the bottom here. And you can even change that into degrees, minutes, and seconds on this page. Okay, and Eric is asking, please say more on how to use a compass. Say I'm at one known point, and I need to navigate through trees to find a peak. Okay. Let's just bring up a map here. Okay, so let's say you're at this point in the center of this little creek here. You're down in this valley, and you know that you're right here. And you want to get up to Grizzly Peak here. So normally what you want to do is place your compass on this map, and you're going to place it so it lines up from the point that you're at to the point that you want to get to. It's going to be diagonally across the map, and then you will rotate the compass ring so that north on the map or on the compass is aligned to your map coordinates or whatever grid you're going to be using on the map. Now you also have to figure declination in there too, so that adds an extra step. Let's see if there's just a diagram here. I think this one kind of showed it. Kind of like this, where you're going to have your compass diagonally across the map, and you can see you line up the north arrows with the grid lines on the map. So you would do that to figure out what direction you need to point your compass to. And then finally, you hold your compass out in front of you. With most compasses, you're going to line up the red arrow, the north arrow, with the actual compass arrow, and that's going to show you where you need to point it. But again, make sure you figure in declination there, which is another topic completely. Okay, and as Paige is saying, we welcome suggestions for future webinar topics. You can send ideas to support@mytopo.com. And if you have a request for a certificate of completion for today's webinar, you can send that to TNP support. It stands for Terrain Navigator Pro, TNP support@trimble.com. This is all in the chat window if you have it up there. And we do have a free trial of our mapping software, Terrain Navigator Pro, and that's at the website terrainnavigator.com. Paige, you want to jump in and add anything else that I forgot to go over, or any closing comments?
No, I'm amazed that we finished on time. I thought this one would go over. So great job, Doug. And if anybody has any questions, we're always available. Support@mytopo.com or TNP support@trimble.com. TNP and our Terrain Navigator Pro and MyTopo are sister companies. We're both owned by Trimble Navigation, or Trimble, I guess it's now called. And happy to help you. And thank you all for being MyTopo customers. We will put this webinar up on the Terrain Navigator Pro YouTube channel. We'll also put a link to it on the MyTopo site. We plan to make this available as a PowerPoint so you can use it and elaborate on it and make it custom for any audience you need to share this information with. Again, Map Tools is a great site. They're longtime partners. They resell our maps. They've made tools that go with all of our custom scales. I did put in the notes, I don't know if everybody saw it, but we have 4 base map types on MyTopo, a topo map, an aerial photo, a satellite image, and a hybrid map. And all of those have different scale ranges. And Map Tools actually sells tools that go with all of our scale ranges. So on the satellite, you can zoom all the way into 1 to 1,000. All of the maps, you can zoom all the way out to 1 to 50,000. And there's lots of scales in between. So it's great to know that you can pick up really inexpensive little plastic grid tools from Map Tools for all of those scales. So with that, I think, let's see, one more question. Will there ever be a personal version of TNP? I've been buying subscriptions at the professional rates. We don't have any, I mean, TNP sells for $240 a year per user per state. You know, if you don't use it much, that sounds expensive. If you rely on it for your business, like a lot of people do, it's a pretty inexpensive option. So we've tried to price it where it sort of meets everybody's needs. If you have some suggestions for features for it or things we can do to make it more useful to you, let us know. But we don't have any plans to come out with a different version of it right now. But anyways, we thank everybody. Between the 2 services, hopefully we're meeting most of your mapping needs. Let us know if you have any suggestions or ideas. And again, thank you all for participating today.